Welcome to EDU World Space.
Here we are, Chapter 4, problem number 6. We have two forces, F1 and F2. We know the direction, we know the magnitude of each force, and part A of this one wants to find the x and y components of the resultant force. We're adding the two together. So let's go ahead and find the x and y components of each force. So let's bring this 9 Newton force out here for a little bit of clarity. And it's making an angle of 60 degrees with the negative x-axis, has a length of 9 newtons. So it has an x component that's going in the negative x direction, and it has a y component that's going straight up. So this would be F1y, this would be F1x. So F1x is the side adjacent to our angle, and we know the hypotenuse, so we're looking at the cosine. So the cosine of 60 degrees is equal to the x component divided by the hypotenuse. So again, hypotenuse times cosine 60 is going to give us the x component, and that, when we plug it into the calculator, is going to give us 4.5. And we do need to be careful because it is pointing in the negative x direction. So we're going to slap a negative on there, 4.5 newtons in the x direction. That's our F1x. So doing something similar for the y component here, this is the side opposite of the angle, so we're looking at hypotenuse times the sine of 60 degrees is going to give us F1 in the y direction. So throwing that into the calculator, we get 7.8, and it's pointing in the positive direction. So let's go ahead and write those in component form. We have F1 is equal to negative 4.5 in the x direction plus, what was that I said? 7.8 in the y direction. Doing a similar work for F2, the x component again is the side adjacent to 53.1. We're talking cosine. The y component, let's just draw those in so you have a visual. We got the x component there, that's the side adjacent to 53.1. Our y component is there. Being careful here because our x component is pointing left, that's negative. Our y component is pointing down, that's negative. Similar sines and cosines here, so writing in F2 in component form, we end up with negative 3.6 I hat minus 4.8 j hat. And to get the magnitude of the resultant, which is F1 plus F2, we're going to add up the I components, we're going to add up the j components. So we're ending up with negative 8.1 I hat, and we're ending up with positive 3 j hat. So there's part A. We've got the x and y components of our resultant. Part B simply wants us to find the magnitude of the resultant. Don't freak out when you hear the word magnitude. They just want the hypotenuse of the triangle. So one leg of the triangle, negative 8.1. So 8.1 in the negative x direction, and 3 units up. Make sure you're adding those things tip to tail, because it gives you the correct direction of the resultant vector, even though we don't need the direction in this particular case. So using Pythag, we're looking at the square root of 3 squared plus 8.1 squared. That is going to give us 8.6 newtons for the magnitude of the resultant force. They don't ask for the direction, but you could go ahead and do an inverse tangent, 3 divided by 8.1, and that's going to give you the angle there. All right, there you have it.